Hello everyone, how are you doing? Hope you're having a great time. This is the end of the year. Today is the 31st of December 2019. Tomorrow is going to be the very first day of the year. It's 4:38 a.m. here in Nigeria, and here I am getting this video ready for you all so you can just learn something great. Again, today I'm going to be showing schematics, designing schematics for the Arduino MIDI pedal board. I know a lot of organists are interested in modifying their keyboards or their pedal boards. I've already done two other videos that I would link to in this video that follow up on this, and they show me making the actual physical connections and testing out the entire thing. So just follow through all the way and you'll see the prototype in action. It's going to be fun, I promise you. Again, the second video, since I'm having to hold the camera myself and at the same time make the connections, it's not as high quality as I would have preferred, but again, if you really pay attention to these fritzing schematics, you don't even need to see that second video at all, because this explains everything in the second video. Again, I usually make a stupid assumption, and that's the fact that I assume you don't know anything about electronics, you don't know anything about breadboards, you don't know anything about schematics. Now, fritzing is a software you can download online. I was able to get this one for free, but I understand it's cost about €8 now to get it. It's worth every penny of it. It's very good stuff. Good for schematics, good for prototyping. It will help you from everything from starting your schematic design to designing a Gerber file that you can upload and send to people that manufacture professional PCBs or printed circuit boards. And these things are so cheap now. At some point PCBs used to be really expensive, but right now they go for about $2 for 5 PCBs. I mean, that's like $2 for 5 PCBs you can use for 5 pedal boards. God, that is really cheap. So without much ado about nothing, let's actually delve right into it. This is a breadboard. All of these lines right here on this rail are electrically connected together. So basically it's like you have a stripped wire running from here all the way down here. Again, all these dots are electrically connected together, so it's like you have a naked wire running from here all the way down here. Now all of these lines, these columns, are electrically connected together. So again, it's like you have another naked wire running from here down here. All of this are electrically connected together. All this are electrically connected together. All this are electrically connected together. And over here, these ones are electrically connected together. Now this and this are not connected together. If you do want to make that connection, you need to run a wire from here to here, and now you have both rails being connected together. Now for over here, all these lines are electrically connected together, and same thing over here. I would delete this wire off right now just because I don't need it. So right now I am going to drag a power source out, which is our battery. I would flip that around, not that way, not that way. Yeah, this would work. So first thing we're going to do is supply power to our breadboard. Convention usually has the positive side of the battery going to the red rail on the breadboard, and the negative side of the battery going to the blue rail on the breadboard. So I would do this. Bam, connected there, and I can pick it up from any point, and bam. So now I am supplying positive power and negative power to this entire breadboard. anything that needs to connect to power, I can connect to this positive and negative rails like I was connecting them to a battery directly. So let's pick out an LED so I can do a connection real quick. LED, just a minute. As you can see at the bottom, it's saying no connections to routes because we've not really made any connection to that route. So I would come here and I'll pick up an LED and I can just place that here. Usually when you get an LED, you don't want to connect your LED to power directly. You usually want to make sure you have like a resistor connected to it. So I'll pick up a 220 resistor. Now the size of the resistor you use for connecting your LED is all determined by Ohm's law. Each resistor has its own forward voltage, and I'm not going to bore you with the calculations for doing the exact calculations for what sort of resistor you should use, but I already know a 220 ohm resistor would work for an LED perfectly. Again, I would for those interested in learning about electronics at a more fundamental level, on my other videos on using the Arduino for building more advanced stuff, I would show things like that. So I will drag this 220 ohm resistor and I'll connect that to the anode of my LED. Now all I have to do is bring this and connect the negative to my cathode here. So that goes to ground, and this goes to positive 5 volts. So what this is doing is like we're taking a wire, connecting it to this resistor, and then now connecting this resistor directly to the positive rail of our battery. So this is one single wire we have here, and for the cathode just the same, one single wire to the negative. As you can see, route completed. So this would light up this LED. We could put in a switch here, but I just don't want to complicate things any further. I think you all get the drift of how the breadboard works. So let me remove this so we can get, oh sorry about that, I didn't mean to delete my breadboard. Yep. So I will take this out, take this out, take this out, and take this out. So in order to get started, first thing I would do is drag my Arduino to the board. Now there are different Arduinos. Again, this is the Arduino Nano, and this is what we'll be using for the main development. The Uno we are just going to be using for our prototyping because it's easier to explain how things work with it. The Nano is fantastic because it fits on a PCB very easily. The Uno you cannot fit on a PCB, so it's more for prototyping. Even the way the wires run, it's not like you can you solder them permanently. They just run into various headers on the board and stuff, you'll see. But with this we can actually get this Nano into a PCB and solder all the legs up. It's fantastic. For our design for the pedal board, again, since we'll be using 3, I'll drag 3 right there just to show how everything just fits nicely on one single breadboard. Oh no, not that. Yeah. And as you can see, bam, all 3 fit nicely on the breadboard. I could bring in a second breadboard and make connections to our buttons and other things, and generate my PCB design, which we can send the Gerber file to be printed online. Again, I'll do all that for you. This is just the prototyping phase, and it's just a proof of concept. So let me get this out of the way real quick. Bam, bam, bam. And I will drag an Arduino Uno on the board. There we go. Next, we're going to need a MIDI jack. In fact, okay, let me bring in the MIDI jack first. MIDI jack. And there we go. I will drag that in and keep it like right here. That is fine. Next, we need a potentiometer. Awesome. Again, I will drag one of those and I will place it like right here. Will be fine. I might drag it down a bit just for space. Yeah, that's fine. And then back to our 220 ohm resistors. So I'll bring those. Now for our potentiometers, for our MIDI jack, these are pins 3, 4 and 5. We're looking at the mirror image. Since we're looking at the front, when we're working with it, we'll be working with it from the back side, so it will be the mirror image. But for connections of the resistors, it doesn't really matter because those are connected this way. I would flip that this way and drag that, so you have one connected to this pin here. The two outside pins we are not going to be using. We're just going to be using the 3 middle pins. This is going to come in right here. Again, I would flip that and bring that in right here. Yeah, better. So as you can see, we have both of these legs connected to this resistors, which are now connected to this rail. Now this middle rail is going to be connected to our ground bus, so to ground, and this rail is going to be connected to our plus 5 volts. Now for our potentiometers, this would go to ground and this to plus 5 volts. Now it doesn't really matter which leg of the potentiometer you connect to ground or plus 5. If you were to flip them around, then the potentiometer will work the opposite way. So when you turn it down, it's like up. I don't know how to explain, but you get what I'm saying. It'll work the reverse way if you were to switch it around, so it doesn't really matter that much. The middle pin of the potentiometer is going to go to our Arduino's analog pin, and we can use any of the analog pins. I just randomly decided to use pin 1, so pin 1 for that. And now we bring in some buttons. So I'd say now we could use reed switches. They have reed switches on here. So these are reed switches, and again I could drag reed switches here for like your pedal board. Now switches typically would always have 2 leads, one positive, one negative. The negative going to your ground rail, the positive going to one of your digital pins on your Arduino. It doesn't matter what type of switch it is. It could be a gold leaf switch like you have on some of these old keyboards. It could be an optical switch or reed switch like you have on some of the more modern keyboards, and they would always have 2 leads, and one is positive, one is negative. It's the same for all switching systems. So I will take this out and use the regular 2 button switches. Now they have certain switches that have like 4 buttons. I would actually show those. So let me just say push buttons. Now these are the variants with four pins. Again, the way this work, one of this is positive, so this could be positive and then this will be negative, or if this were positive, this will be negative. So this sort of 4 pins help you where you can actually have one switch controlling 2 circuits. So again, it's still 2 legs: positive, negative, positive, negative. So I would delete that since I'm going to be using the two leg variant, and I will drag one here. I'll drag a second one right here. I'll just be using 3 for this prototype just for the sake of simplicity, and the third one here. And now for our buttons, we take this leg and plug to ground. This leg goes to ground, and this leg goes to ground. Now all these other legs would go from pins 4 to 2, so this can go to pin 4. This is pin 4. You can see D4, and this will go to pin 3. You can see D3 right there, and this can go to pin 2. You can see D2, so digital pin 2. So we have our 3 buttons connected to the 3 digital pins, and our potentiometer connected to the single analog pin. The next thing will be to supply power to our breadboard, and to do that we can take the ground from our Arduino. Again, if I move my mouse over it, you should see ground. So I'll take ground from there to this blue rail, and this is 5 volts, so you can see 5V, and I'll take 5 volts to my 5-volt rail. So my breadboard is now supplied with power. Now the last thing to do to complete this circuit would be to connect the third leg of our MIDI jack to the transfer pin. So you can see D1TX. TX stands for transfer. Now since we are going to be sending MIDI messages, so invariably somebody pushes a pedal button, it sends a MIDI message to the computer. We are transferring, and that's why we're using the transfer pin. Now in a situation where we wanted to receive MIDI, so for instance for our draw knobs on our stop console, we would want to receive MIDI message. So if I was to push like a piston, and some LEDs are meant to go off while some come on, would want that would be receiving message, and in that case would be using our RX pin. You can see D0RX, that is for receiving. But since we are not receiving anything for this circuit, we're just transferring, we're just going to use the TX. When we're building the prototype for our console for the draw knobs, we're going to use both the transfer pin and the receiving pin, because we're going to want to transfer MIDI. So when somebody pushes a button, a particular stop lights up, and when somebody pushes a piston, the same stop goes off based on the way you have things set up. So there we go, our Fritz diagram is complete, and this is how you are going to do your connection. I hope it is very clear. Please, if you do have any questions, let me know. Again, all the components you need are right here. A MIDI jack, I was able to get 2 of these MIDI jacks, and an octocoupler from a junkyard. They had a MIDI keyboard laying around there, and the guy that owned the MIDI keyboard allowed me to just pick out the MIDI jack and the octocoupler from the MIDI keyboard. I desoldered them, and I paid him like 10 cents or thereabout, really cheap. These resistors are so cheap, I don't even know how much. They don't sell them singly. Yeah, they usually sell like 100 of them for like 10 naira or thereabout. They're so cheap. The potentiometers, I don't know, I bought maybe about 200 of them or 300 of them for 3,000 naira. That's like 30 naira for one. That's just about a cent. Push buttons are equally very cheap. They go for about 10 naira a piece, so that's like a cent. The most expensive would be your Arduino, the Arduino Nano. Arduino Nano here in Nigeria goes for 1,500 a piece. In US dollars, that would be about $2 or less than $2. So $2 for one nano. Using 3 nanos for your pedal board means you're spending about $6 on the Arduino, and when you couple the price for everything else including your PCBs, man, the entire circuit is going for less than $15. So for less than $15 you can modify your pedal board and you know you did it by yourself. So again, please, if you do have any questions, let me know. I'm more than willing to answer all your questions. There are videos that follow this one and they actually show me making the physical connections. Again, I apologize, I had to hold my phone in one hand and make the connection with the other hand, so it's not a very fantastic video. And the third video actually shows me testing everything. I hope everything is really clear and lucid, but again, if it's not, please send me a message. My email is ade.thompson@delay.ng. Thank you for your time. I appreciate you so much. Happy New Year and God bless you. Bye bye.